Section 10.2 is on arithmetic sequences and series. The nth term of an arithmetic sequence is a sub n equals a sub 1 plus n minus 1 times d, where a sub n, and I'm saying sub for subscript, so a with a subscript of n, or a sub n, is the nth term, a sub 1 is the first term, n is the number of the term that we're given, and d is the common difference. Let's take a look at several examples. This says find the indicated term of the arithmetic sequence. So we need to find a sub 20 given that a sub 1 is 15 and my common difference is negative 8. So let's start with our formula. A sub n equals a sub 1 plus the quantity n minus 1 times d. And I know that n is going to be equal to 20. It's because I have a sub 20. And let's plug in the numbers that we know. So I need to find a sub 20. I don't know what that is, but it's going to be 15 plus n was 20 minus 1 times my common difference of negative 8. Notice that I put that negative 8 in parentheses because d is actually being multiplied by the quantity n minus 1. If I didn't put the parentheses, I might get confused and think I was subtracting 8. So now all we have to do is simplify this. So a sub 20 is equal to 15 plus 19 times negative 8, or 15 minus 152, or a sub 20, or the 20th term in the sequence, is negative 137. Here's another example. This says write an equation for the nth term of each arithmetic sequence. So we're given the first three terms of the sequence, but I want to write an equation where I can say, for example, maybe I want to know the 15th term of the sequence, so I would just plug in 15 for n. So I'm going to need to write an equation to do that. So looking at this, I know that my first term is negative 8, and I know that my common difference, notice I'm adding 2 each time, so my common difference, or d, is equal to 2. So I'm going to use my basic formula, a sub n equals a sub 1 plus n minus 1 times d. And in this case, n is going to be my variable. It's going to be kind of like x in an equation. So I'm not trying to find what n is. So a sub n equals negative 8 plus n minus 1 times 2. Let's distribute that 2 to the n and to the negative 1. A sub n is equal to negative 8 plus 2n minus 2. And now I'm going to write it in this form. A sub n equals, I'm going to put my 2n first, and negative 8 minus 2 is a negative 10. And that's what my equation is going to look like. Remember in the previous section how we talked about how an arithmetic sequence is linear. Well, this is actually the equation of a line. And as the equation of a line, it's written actually in y equals mx plus b form, where a sub n is equivalent to y, your slope is 2, n is my variable, and negative 10 is my y-intercept. So when you're writing the equation for the nth term, put it into this form. Kind of looks like y equals mx plus b. Our second example gives us a sub 6 equal to 11, and d is equal to negative 11. Okay, so from that I know that my n is going to be equal to 6 because this is the sixth term. I know that the sixth term is 11, but what I don't know is a sub 1, and I really need that to write my equation. So I'm going to start out by finding a sub 1. So I use my formula, a sub n. Nice thing about this section is it uses the same formula for everything, so you don't have to choose which formula to use. Okay, and I know that when n is 6, a sub 6 is 11, so I'm going to plug that in here. So 11 is equal to a sub 1, which I don't know, plus 6 minus 1 times negative 11. So 11 is equal to a sub 1 plus 5 times negative 11. Keep solving that. Oops. Keep solving that for a sub 1, and then adding 55 to each side. A sub 1 is equal to 66. Now I can write an equation that has n in it as the variable. So a sub n is equal to my a sub 1, which is 66, plus n minus 1 times my common difference of negative 11. Now notice in this one I put the n back in just as n, not as 6, because that's going to be my variable. Now I just need to simplify this. 66 and distributing negative 11 minus 11n plus 11, or a sub n is equal to negative 11n plus 77. And that's the equation I could use to find the nth term of this sequence. Arithmetic means. The arithmetic means are the terms between two non-consecutive terms of an arithmetic sequence. So for example, here we have an arithmetic sequence, but we have 3 blanks in the middle. I have basically 5 terms, but I don't know what the middle 3 are. And those are called the arithmetic means. So I know that my first term is 21. I know that my fifth term is 45, but what I don't know is what my common difference is. But I do know that when n equals 5, let me move this down a little bit here. When n equals 5, a sub 5 is equal to my first term. Actually, let me go ahead and put the formula in here for you. So a sub n equals a sub 1 plus n minus 1 times d. Okay, I'm going to use my n equals 5, so a sub n is 45, which equals 21 plus 5 minus 1 times d. I'm going to subtract 21 from both sides. That gives me 24 equals, that's going to give me a 4d. So d is equal to 6. That's my common difference. So remember what that means is that when I go from my first term to my second term, I'm adding 6. So my second term is going to be 21 plus 6, or 27. My third term is going to be 27 plus 6, or 33. And my fourth term is going to be 33 plus 6, or 39. And those are the 3 arithmetic means between 21 and 45. Now a series is the sum of the terms in a sequence. So you have this whole sequence of terms. If you just add them up, you get the series. An arithmetic series is the sum of the terms of an arithmetic sequence. And a partial sum is a sum of the first n number of terms, and that's denoted by a capital S sub n. And for that we actually have 2 formulas. If we know what a sub 1 is and a sub n is, then here's the formula for the sum, partial sum of an arithmetic sequence. N times the quantity a sub 1 plus a sub n divided by 2. If you're given a sub 1 and the common difference d, then you can use this formula. But I think I really like the first one. I think I'm going to end up using that in most of my examples. So let's take a look at a couple examples of that. Find the sum of each arithmetic series. So this one starts with 8, then it goes to 12, 16, and a certain number. We don't know how many more numbers are in between there. And the last one is 80. So let's go ahead and identify some things that we know here. I know that a sub 1 is 8, and I know that a sub n is 80. I know that my common difference is 4. You'll notice I'm adding 4 each time. But what I don't know is how many terms are in the series. So let's go ahead and use our first formula to figure out what n is equal to. So a sub n equals a sub 1 plus n minus 1 times d. And I know that my nth term is 80. a sub 1 is 8 plus, I don't know what n is, minus 1 times my common difference, which is 4. So let's go ahead and simplify that. Let's solve that for n. 8 plus, and now distribute this 4n minus 4, or let's see, and then that's going to give me 80 equals 4n plus 4, subtracting 4 on each side, and then dividing both sides by 4 gives me n equals 19. Now I can use my sum formula. And I think I'm going to use that first one. S sub n equals n times a sub 1 plus a sub n over 2. And now I have all of those values and I can just plug them in. So n is 19, a sub 1 is 8, a sub n is 80 divided by 2, or 19 times 88 over 2, or 19 times 44, which gives me 836. So the sum of those first 19 terms from 8 to 80 is 836. Let's take a look at another example here. Here we're given that n equals 16, a sub n, or the 16th term, is 240, and my common difference is 8, but I don't know what a sub 1 is. So I can figure that out using my first formula. Okay, so a sub n is 240, a sub 1 I don't know, plus n is 16 minus 1 times my common difference of 8. So 240 equals a sub 1 plus 15 times 8 is 120, or a sub 1 is equal to 120. Now I can use my formula. S sub n equals n times a sub 1 plus a sub n over 2. So n is 16 times a sub 1, 120, plus a sub n, which is 240, over 2. So just simplifying that is going to give me, plugging that into my calculator, so 360 divided by 2 times 16 gives me 2,880. And let's try this one here. Find the first 3 terms of this arithmetic series. So I'm given the total of the series, the partial sum. I'm given the first term, sorry about that, and the nth term, but what I don't know is n, and the other thing I don't know is what is d. So since I'm given the sum, I can go ahead and use that formula. S sub n equals n times a sub 1 plus a sub n over 2, because I do have that information. And I can use that to find n, so my total, my sum is 129, and that's equal to n times 14 plus 29 over 2, and solving that for n equals 14 plus 29 divided by 2 is 21.5 n, and dividing both sides by 21.5, n is equal to 6. Now I can use this to find my common difference. And the reason I need to find the common difference is the problem's asking me for the first 3 terms. So I know what the first term is, but I need to know what to add to that to get my next term and my next term. So we're going to use our first formula here. Okay, and a sub n is 29, a sub 1 is 14, n is 6, and I don't know what my common difference is. So I'll go ahead and subtract that. That's going to give me 15 equals 5 times d, or d is equal to 3. So if my first term is 14, my next term adds 3 to that and gives me 17. My next term adds 3 to that and gives me 20. And they actually asked for the first three terms. The first term was 14, second term is 17, and the last term is 20. And the last thing we're going to take a look at in this section is something called sigma notation. And this is a shorter way to write the sum of a series. And so what we use is the Greek letter sigma. This is an uppercase S in Greek. The formula is going to be out front here. The number underneath is the first value of k that we're going to use, and the number on top is the last value of k that we're going to use. And this looks very confusing, but let's go through an example. So here we have to find the sum of this series. So looking at this, I know that my first value that I'm going to plug in is 9. I know that my last value that I'm going to plug in is 21, but I don't know the number of terms. So my number of terms is going to be my last value minus my first value. And actually, this is kind of a rule of counting. Whenever you're counting, if you're given the first value and the last value, you subtract them and add 1 to get the total number of terms. So in this case, n is going to be equal to 13. So a sub 1 is what I'm going to get when I plug my first term, which is 9, into this formula. So a sub 1 is 5 times plugging in 9 for k plus 6. So this is 5k plus 6 when k is equal to 9. That gives me 51. My last term, my 13th term, is going to be 5 times my last value I plug in is 21 plus 6, or 111. And that's going to be like my a sub n. Now I'll use the sum formula. S sub n equals n times a sub 1 plus a sub n over 2. And I have all the values I need to plug in there. So the sum of the first 13 terms is 13 times a sub 1 is 51 plus a sub n, which is 111, over 2. And plugging that into my calculator, I get 1053. So in this section, we took a look at arithmetic sequences and had a formula, a little equation of how to find the arithmetic, an equation for the arithmetic sequence. And we also talked about arithmetic series and how to find partial sums.